So this is a guided walkthrough for Day 5 of TryHackMe's Advent of Cyber event. It is task number 11, and let us begin. So the days in Wareville flew by, and software's projects were nearly complete, just in time for Christmas. One evening, after wrapping up work, Software was strolling through the town when he came across a young boy looking dejected. Curious, Software asked, "What would you like for Christmas?" The boy replied with a sigh, "I wish for a teddy bear, but I know my family can't afford one." This brief conversation sparked an idea in Software's mind. What if there was a platform where everyone in town could share their Christmas wishes, and the mayor's office could help them make them come true? Excited by the potential, Software introduced the idea to Mayor Malware, who embraced it immediately. The mayor encouraged the team to build up the platform for the people of Wareville. Through the developers' dedication and effort, the platform was soon ready and became an instant hit. The townspeople loved it. However, in their rush to meet the holiday deadline, the team had overlooked something critical. Thorough security testing. Even Mayor Malware had chipped in to help develop a feature in the final hours. Now it's up to you to ensure the application is secure and free of vulnerabilities. Can you guarantee the platform runs safely for the people of Wareville? Okay, so let's take a look at today's learning objectives. Understand the basic concepts related to XML. Explore XML external entity, XXE, and its components. Learn how to exploit the vulnerability. Understand remediation measures. All right, so we're going to be talking about this concept over here called extensible external entities. So we need to learn a couple of things first. So some important concepts include something like extensible markup language, which is called XML. XML is a commonly used method to transport and store data in a structured format that humans and machines can easily understand. Consider a scenario where two computers need to communicate and share data. Both devices need to agree on a common format for exchanging information. This agreement format is known as XML. You can think of XML as a digital filing cabinet. Just as a filing cabinet has folders with labeled documents inside, XML uses tags to label and organize information. These tags are like folders that define the type of data stored. This is what an XML looks like, a simple piece of text information organized into a structured manner. Okay, so we've got inside these people tags here, there's these name tags here identifying a name, which is glitch. And then inside the address tags here, there's an address, which is Wareville. And then the email is inside the email tags, and the phone number is inside the phone tag over here. All right. In this case, the tags people, name, address, etc. are like folders in the filing cabinet, and now they store the data about glitch. The content inside the tags like glitch, Wareville, and this number over here represent the actual data being stored. Like before, the key benefit of XML is that it is easily shareable and customizable, allowing you to create your own tags. So we're talking now about the document type definition, otherwise known as the DTD. Now that the two computers have agreed to share data in a common format, what about the structure of the format? Here is where the DTD comes into play. A DTD is a set of rules that defines the structure of an XML document. Just like a database scheme, it acts as a blueprint, telling you what elements, tags, and attributes are allowed in an XML file. Think of it as a guideline that ensures that XML documents follow a specific structure. For example, if we want to ensure that an XML document about people will always include a name, address, email, and phone number, we would define those rules through a DTD as shown below. Okay, so over here, so the doc type is about people. These are the different elements that need to go into the document. So in people, we need a name, address, email, and phone number. In the above DTD, element defines the elements or tags that are allowed, like name, address, email, and phone, whereas PC data stands for parsed people data, meaning it will consider of just plain text. Okay, so next let's talk about entities. So far, both computers have agreed on the format, the structure of the data, and the type of data that they will share. Entities in XML are placeholders that allow the insertion of large chunks of data or referencing internal or external files. They assist in making the XML file easy to manage, especially when the same data is repeated multiple times. Entities can be defined internally within the XML document or externally, referencing data from an outside source. For example, an external entity references data from an external file or resource. In the following code, the entity and ext could refer to an external file located at http tryhackme.com robots.txt, which would be loaded into the XML if allowed by the system. Okay, so there's an entity, it's an external, and it will include this file right here at this URL. Okay. We're specifically discussing external entities because it is one of the main reasons that XXE is introduced if not properly managed. XML external entity, XXE. After understanding XML and how entities work, we can now explore the XXE vulnerability. XXE is an attack that takes advantage of how XML parsers handle external entities. When a web application processes an XML file that contains an external entity, the parser attempts to load or execute whatever resource the entity points to. If necessary, sanitization is not in place, the attacker may point the entity to any malicious source or code, causing the undesired behavior of the web app. For example, if a vulnerable XML parser processes this external entity definition, so over here, entity THM file is equal to file, etc. password. So this is referencing the local system and the file, etc. password. This, of course, assumes that we're on some sort of Linux or Unix system. So here the and THM file refers to the sensitive file, etc. password on a system. When the XML is processed, the parser will try and load and display the contents of that file, exposing sensitive information to the attacker. In the upcoming task, we will examine how XXE works and how to exploit it. Okay, so connecting to the machine. Before moving forward, review the questions in the connection card shown below. Do we need to start the attack box today? Yes. Do I need to start a VM today? Yes. Okay, so we're going to click on the green start button below to start the virtual machine. So alright, we're going to break here and we're going to start up the machines that are required for today's exercise. First of all, click on this green Start Machine button over here, and then after you've done that, go up to the top of the web page, and at the top of the web page, click on Start Attack Box. This is going to start up the 2 virtual machines we need to solve today's challenge. So go ahead and at the top of the web page here, click on this button called Start Attack Box, and then you'll see that your browser pane is going to split into 2. So the left-hand side here is the TryHackMe webpage, and the right-hand side here is the attack box, which is loading up. So the attack box is going to take about 1 or between 2 and 3 minutes, I think, to load up. So while it's loading up, what we're going to do is we're going to review what else we're going to be doing in this room. So we're just going to scroll back down. Over to here. Okay, so we're now at the practical section. So now that you understand the basic concepts related to XML and XXE, we will analyze an application that allows users to view and add products to their carts and perform the checkout activity. You can access the Wareville application hosted on this IP address right here. This application allows users to request their Christmas wishes. Okay, so what is the flow of the application? As a penetration tester, it is important to first analyze the flow of the application. First, the user will browse through the products and add the item of interest to their wish list at this endpoint right here, which is the product.php endpoint. Click on the Add to Wish List under Wareville's Jolly Cap as shown below. Alright, so we need to wait for a little bit while the attack box finishes initializing over here. Okay, so our attack box is finished loading up. We just need to click into this terminal over here and hit enter to dismiss it. And then we're going to start up the attack box's web browser. So the web browser in this case is Firefox. And you just need to click on this button and start it up. And afterwards we can access the product page over here. So let's copy the URL for the product page. And then afterwards in the attack box web browser, let's paste, oh, it doesn't want to paste. Okay, so we're going to have to click on this button over here, the control bar, and open up the clipboard. So in the clipboard, we're going to paste in the URL for the product page. Then we're going to close the clipboard, and then we're going to highlight the URL address bar and paste in the product page. Hit enter, and then we will be at the web app. Okay, so it looks like, well, this view is a bit big. Let me shrink this down a little bit. It also looks like the web browser is a bit slow to respond. Let me try to shrink this down. Yeah, okay. All right, this looks a little bit better. Let's shrink this down a little bit more, and maybe a little more. Okay, this is better. All right, so we need to add this to our wish list. So we can just click on this button here, which is labeled Add to Wish List. And it says Item successfully added to the wish list. And then we need to access the wish list. So it says here, after adding products to the wish list, click on the cart button or visit this page to see the products added to the cart. So what we can do is there's supposed to be a button over here. Okay, we can click on this button over here that's called cart. And then we see here that the cap has been added to our cart. And then we're going to proceed to the checkout. So just click on this button here. And then we need to fill in some information. So full name and then address. So for this one over here, I'm going to fill in HackerFrogs, like and subscribe. And for the address, I'm going to put in test. And then I'm going to click on this button here, which is labeled complete checkout. All right, it says wish successful. Your wish has been saved as wish number 21. So it says wish 21 indicates that the wishes placed by a user on the website. Once you click on wish 21, you will see a forbidden page because the details are only accessible to admins. But we can try to bypass this and access other people's wishes. This is what we will try to perform the task. So like the page says, if we try to click on this link over here for wish number 21, we'll see this error message over here. It says error, Santa's elves are the only one that can read wishes, smiley face. Okay, so it says here what we're going to do is we're going to intercept the request. Before discussing exploiting XXE on the web, let's learn how to interpret the request. First, we need to configure the environment so that, as a pen tester, all web traffic from our browser is routed through Burp Suite. This allows us to see and manipulate the requests that we browse. We will use Burp Suite, a powerful web vulnerability scanner, to intercept and modify requests for this exploitation. You can access Burp Suite in the attack box. On the desktop of the attack box, you will see a Burp Suite icon as shown below. So this is the icon for the Burp Suite Community Edition. So first of all, what we need to do in the attack box is we need to minimize the window for the web browser. And then afterwards, we need to click on the Burp Suite Community icon, which is located right here. So at the right-hand side of the screen, there's this blue icon. It's labeled Burp Suite Community Edition. Go ahead and click on that. And then Burp Suite is going to start up. So it's going to take just a little bit to load up. Okay, so what else do we see here? Once you click on the icon, Burp Suite will open with its introductory screen. You will see a message like "Welcome to Burp Suite." Click on the next button. Okay, so this is the introduction screen that the page was talking about. So just click on the orange next button over here, and then click on the orange Start Burp button over here. So after that, you're going to see Burp Suite load up. So it says here, once Burp Suite has started, you will see its main interface with different tabs, such as Proxy, Intruder, Repeater, and others. So we're just going to dismiss this message here. So we've got our dashboard, our target, our proxy, our intruder. So these are all the different Burp Suite tools, and we're going to be interacting with them in just a second. Inside Burp Suite, click the Settings tab at the top right. You will see Burp's Browser option available under the Tools section. Enable Allow Burp's Browser to run without a sandbox option, and then click on the Close icon on the top right corner of the Settings tab as shown below. So this is what we're going to do. We're going to go over to the Settings button over here, and then we're going to click on it. And then afterwards, we're going to click on this over here, which is labeled Burp's Browser. And then we're going to go down to the Browser Running section over here. So this is a special setting that you have to enable in order to get Burp's Browser to start on the attack box. So go ahead and click on that button over here, and then afterwards we can close out the settings. So after this is checked, we go up to the Settings Close Window button and close it. Okay, and then afterwards we're going to go to the Proxy tab. So we go from the Dashboard tab to the Proxy tab over here. So click on that, and then what we need to do is we need to click on the Open Browser button. So in the Proxy tab, we click on the Open Browser button over here, and that's going to start up the Burp browser. The Burp browser is a web browser that is connected to Burp Suite. So while that opens up, we're going to get the URL for the product page one more time, and it's over here. So I'm just going to copy this, and then I'm going to open up my clipboard, and in the clipboard I'm going to paste in the URL for the product page. After we've done that, we're going to go to Burp's browser over here, and this is the Burp Suite browser. It automatically opens up to the Portswigger website here. That's normal. So just click on the address bar and then paste in the URL for the web application product page. So after you've done that, hit enter. Oh, it looks like there's one more thing we need to do. Okay. So the reason why this isn't going is because we haven't set the proxy properly. So, okay, we're going to minimize the Burp Suite browser, and then we're going to go to Proxy and then Intercept. So we need to click on Intercept here, and we need to click on this button that says Intercept On, and we need to make sure that it says Intercept Off. So this is something we should do every time we start up Burp Suite, because otherwise it's going to make interacting with the Burp Suite browser very difficult. So go ahead and click Intercept On, and it'll switch Intercept to Off. And this is what we want, because when Intercept is on, we have to manually approve each one of our web requests, which is a big pain in the butt. So now that Intercept is off, we're going to minimize Burp Suite, and then we're going to go back to the Burp browser over here. Okay, so we should be on the Wareville wishlist page. So let's make this a little smaller. Okay, so we can click on add to wish list on the Wereville's Jelly Cap item over here. And then after we've done that, we can scroll over to this button over here. And this button, if I can, okay, so click on the button and then click on the cart. Okay, so now that we're on the cart page, we can click on Proceed to Checkout. And then once we're at Proceed to Checkout, we need to put in our name and our address again. So it's going to be HackerFrogs, like and subscribe, and the address is going to be test. So after that, we're going to click on Complete Checkout. Okay, so it says wish successful, your wish has been saved as wish number 22. All right, so now let's go back to the TryHackMe page and see what's going on here. Okay, so we started up Burp Suite, and then we did all of our settings over here. So after allowing the browser to run without a sandbox, you will now be able to start the browser with the preconfigured Burp Suite's proxy, navigate to the Open Browser button. Okay, so we've done that. And browse to the URL so that all the requests are intercepted. Yes, we've done that. Okay. Once you browse the URL, all of your requests are intercepted and can be seen under the Proxy HTTP History tab. So let's demonstrate this. So let's minimize the browser in the attack box and then go over to Burp Suite. Inside of Burp Suite, under Proxy HTTP History, so once again, that's Proxy HTTP History. Just click on the History tab here. We see that all of the different requests that we sent to this IP address, they've all been recorded. So we've got our wish list, posting our wish list, and then when we go to the cart, we've got our requests over here. So this is where we have our request, and then we can also see the response by clicking on this tab over here. These are the responses that the web browser sent to our web browser. The web server. This is what the web server sent to our web browser, rather. Okay. So it says here, what is happening in the backend? Now, when you visit this URL, so the product page, and click on Add to Wishlist, an AJAX call is made to the wishlist.php with the following XML as input. So we've got here, so inside this wishlist, so this is a XML code over here, and it's being sent to wishlist.php. In the above XML, product ID tag contains the ID of the product, which is 1 in this case. Now let's review the Add to Wishlist request logged in Burp Suite's HTTP History option under the Proxy tab. As discussed above, the request contains XML being addressed as a post request, as shown below. Okay, so let's take a look at wishlist.php. So this is a post request, and under the Proxy HTTP History tab, you should be able to see this one over here. You'll see the URL goes to wishlist.php, and it is a post request, as opposed to these other ones which are get requests. So go ahead and click on the wishlist request over here, and then we're going to scroll. I think I can make this a little bigger. Okay, and then we're going to scroll down inside the request. So inside the request, this is the XML code that they're talking about right here. So wishlist item product ID is equal to 1, okay? User ID is equal to 1. So let's take a look at what's going on here. The wishlist.php accepts the request and parses the request using the following code. So it's going to echo item added to your wish list successfully. After it does, it sets up a variable over here, and I'm not completely sure what the PHP code is doing, but it echoes item is added to your wish list successfully. All right, so preparing the payload. When a user sends specifically crafted XML data to the application, the line this one over here, libxml disable entity loader false, allows the XML parser to load external entities. This means the XML input can include external file references or requests to remote servers. When the XML is processed by simple XML load string with the libxml noent option, the web app resolves external entities, allowing attackers access to sensitive files or allowing them to make unintended requests to the server. What if we updated the XML request to include references for external entities? We use the following XML instead of the above XML. We will use the following XML instead of the above XML. So what we're doing here is we're adding some extra information to the XML data here. So doc type is going to be foo, and it's going to be an entity with the I guess it's going to be called payload, and the system is going to be the file that's going to be used is etc hosts. All right, and we also include the word payload inside of the XML over here. When we send this updated XML payload, the first two lines introduce an external entity called payload. The line entity payload system etc hosts tells the XML parser to replace the and payload reference with the contents of the file etc hosts on the server. When the XML is processed, instead of a normal product ID, the application will try and load and include the contents of the file specified in the entity etc hosts. Exploitation. Now let's perform the exploitation by repeating the request we captured earlier. The Burp Suite tool has a feature known as the repeater that allows you to send multiple HTTP requests. We will use this feature to duplicate our HTTP post request and send it multiple times to exploit this vulnerability. Right-click on the wishlist.php post request and click on Send to Repeater. Okay. So, alright, so what we're going to do is we're going to click on, so this is the request right here. It's the post request to wishlist.php. And what we need to do is we need to right-click on it and then select Send to Repeater. This option over here, after you right-click. You're going to see the Repeater tab light up orange like this. Afterwards, you can click on the Repeater tab, and you're going to see that the request has been sent to the repeater here, and we can actually replay this request multiple times in order to exploit the this web app. Okay. So we've just done what was requested over here. Place the mouse cursor inside the repeater tab in Burp Suite and press Ctrl-V or paste the payload in the above highlighted area. Okay, so what we're going to do is this. We're going to go ahead and grab this XML here. So we're just going to grab all of it, and then we're going to copy, and then we're going to go over to this button over here, and we're going to paste this into the attack box's clipboard. So we're going to delete whatever is already in the clipboard, and then we're going to paste. We're going to see the code get inserted into the clipboard. Then we're going to close the clipboard with this button here. And inside of the Burp Suite repeater over here, we're going to highlight all of this code. So we're going to go up. We're going to highlight all the code over here, and we're going to delete it. So hit delete. And then afterwards, we're going to paste in the code from the TryHackMe website. So select and use this button over here, paste. Okay. So this is the new payload that inserts a new XML entity with a request. So what this request is trying to do is it's trying to read the etc host file on the web server. So as soon as we click the send button here, then the request is going to go through. And we need to click on the response tab to see what actually was the response from the request. So you see here that we actually do have, we do get the output from reading the etc host file on the web server. So another interesting thing about Burp Suite is we can actually see this as it would be rendered out on a web browser. We just need to So inside the response, we can go from pretty to raw to hex to render. So render is the button we want to do. We want to click on to get the web browser view for this output. So it says loading. Okay, so this is what we would see if this was rendered inside a web browser. So this is the contents of the etc host file, which means we did manage to read a file, a protected file on the web browser, on the web server. Okay. Okay, so we just did all of this stuff over here. Okay, so when we click send, the server processed the malicious XML payload, which included the external entity reference to etc hosts. As a result, the wishlist.php page responded with the contents of the etc host file, leading to an XXE vulnerability. So it is time for some action. Now that you've identified a vulnerability in the application, it's time to see it in action. MixKitty software has tasked us with finding loopholes, and we've successfully uncovered one in the wish.php endpoint. But our work doesn't end there. Let's take it a step further and access the potential impact that this vulnerability can have on the application. So earlier we discovered a page accessible only by administrators, which seems like an exciting target. What if we could use the vulnerability we've found to access sensitive information, like the wishes placed by the townsfolk? Now that our objective is clear, let's leverage the vulnerability we discovered to read the contents of each of the wishes pages and demonstrate the full extent of this flaw to help MixKitty secure the platform. To get started, let's recall that the page is only accessible by admins /wishes wish1.txt. Using this path, we need to guess the potential absolute path of the file. Typically, the web applications are hosted on var www.html. With that in mind, let's build our new payload and read the wishes while leveraging this vulnerability. Okay, it says, note, not all web applications use the path var www.html, but web servers typically use it. Okay, so what we're going to do is we're going to use this new payload over here, and this is very similar to the other payload we were using, except that the file path has changed, and we're going to change our file path to var www.html, which is wish1.txt. So let's do this manually. So over in the request portion over here, we're going to modify the file path over here, and we're going to change it from etc hosts to var www.html wishes wish_1.txt. Okay, so after that's done, we're going to click on send, and then we're going to go to the response. So in the response, it says product. Okay, so we were able to read the contents of the wish.txt file over here. So surprisingly, we got lucky that our assumption worked. The next thing to do is see whether or not we can view more wishes using our discovery. To do this, let's try replacing the wish1.txt with wish2.txt. So let's go back. We can change up the number for the wish from wish1 to wish2, and then send this, and then take a look at the response. So what we need to do is we need to keep on iterating over the number of wishes, and what we want to do here is we want to find a flag. So I'm going to give you a heads up that the wish that we actually want to read is wish number 15. So after we send this request, inside the response, we see a flag. So the flag is THM brute forcing my way. Okay. So when we use the web browser view, we actually can't highlight anything. So we're just going to go back to the pretty view over here, and then we're going to copy the flag. So just copy the flag, and then go over to this button over here, and go to the clipboard, and then highlight this over here, THM brute forcing my way, copy it, then go down to here What is the flag discovered after navigating the wishes? We're going to submit this flag here and then click on submit. Okay, that's done. Then we're going to go back up and we're going to finish off today's exercise. So as a result, we were able to view the next wish. You may observe that you just incremented the number value by 1. Given this, you may continue checking the other wishes and see all the wishes stored in the application. So we just took a look at a few different wishes, and we were able to get the flag by accessing flag number 15. So after iterating through the wishes, we have proved the potential impact of the vulnerability, and anyone who leverages this could read the wishes submitted by the townspeople of Wareville. It was confirmed that the application was vulnerable and the developers were not at fault since they only wanted to give the townspeople something before Christmas. However, it became evident that bypassing security testing led to an application that did not securely handle incoming requests. So as soon as the vulnerability was discovered, McSkitty promptly coordinated with the developers to implement the necessary mitigations. The following proactive approach helped to address the potential risks against XXE attacks. So what can we do to mitigate against XXE attacks? We can disable external entity loading. The primary fix is to disable external entity loading into your XML parser. In PHP, for example, you would prevent XXE by setting libxml disable entity loader true before processing the XML. And we can also validate and sanitize user input. Always validate and sanitize the XML input received from users. This ensures that only expected data is processed, reducing the risk for malicious content being included in the request. For example, remove suspicious keywords like /etc host, /etc password, etc. from the request. After discovering the vulnerability, McSkitty immediately remembered that a changelog file exists within the web application, sorted the following endpoint, so the URL and then changelog. After checking, it can be seen that someone pushed the vulnerable code within the application after software's team. Okay, so what we need to do is we need to access this on our own inside the inside our web browser. So in the attack box, we're going to minimize Burp Suite, and then we're going to go back to the to our regular web browser inside the attack box, and here we're going to modify the address bar, and after the number 51 and the slash, we're going to delete everything, and we're going to replace this with changelog, and then hit enter. Okay, so we've got some. So fix the web wishlist.php page, and then we have a flag over here, THM Mayor Malware Backdoors. All right, great. So we're going to copy this flag, and as usual, we need to go over to our clipboard over here, and in the clipboard, highlight the flag and copy it again, close the clipboard, and then go down here. So before we submit the flag, let's finish off the text for today's lesson. So with this discovery, McSkitty still couldn't confirm whether the mayor intentionally made the application vulnerable. However, the mayor had already become suspicious, and McSkitty began to formulate theories against his possible involvement. Okay, so we're going to answer the questions to finish off the room. The second question is, what is the flag seen on the possible proof of sabotage? So that was the changelog file. We click into here, paste in the flag, click on submit. And the next question is, if you want to learn more about XXE injection attack, check out the XXE room. Okay, we don't need to answer a question. Click on complete. And here, following McSkitty's advice, software recently hardened the server. It used to have many unneeded open ports, but not anymore. Not that this matters in any way. Okay, so this might be some sort of hint as to the advanced challenge, but we're not going to be covering the advanced challenge in these walkthroughs. Anyways, click on complete, and then we're finished. We're finished day 5. Okay, so thank you very much for watching this guided walkthrough of day 5 of TryHackMe's Advent of Cyber event. There are many more days to go, and we will see you next time.
Hey there, HackerFrogs! Are you enjoying this workshop? Learning new concepts and skills? If so, there's a way you can support the channel, and it's totally free. Just click on the subscribe button below the video. Also, click on the like button, and if you have questions or comments on this workshop, please leave them below the video. Thanks for listening. And now, back to our scheduled programming.